Hey, welcome back to Made of Wires. We're decompiling Castlevania Symphony of the Night. Give me 1 second while I finish off something that I didn't realize was going to be done when I started the stream. 1 second for me to double check some output. Hope everybody's having a great day. I've been working on deduping a bunch of the stuff from the Olrox boss fight in for the PSP version, and I guess I never considered what the impact of orphan removal was from the code base, but it looks like MWCC will automatically remove unused functions even if they're in objects that are unrelated. And so when matching comes in and determines that two objects are identical or not, that's based on the concept of the original PlayStation version, where automated orphan removal wasn't part of that process. And so I'm seeing why some of these pieces don't necessarily match now, even though maybe individual functions do, but it's because there are some functions that just aren't used, and so they're automatically culled. Almost done. 1 second. Sorry about the delay. There we go. All right, let's get into it. So we've been working on Olrox. We're working on kind of the big bad state machine function. Oh, by the way, go to certain.z.dev. This isn't my project. I'm a contributor, and I like decompiling, reverse engineering, and things like that. And that's why I contribute, and that's why I'm streaming and enjoy talking with everybody who shows up and see what we can get done each stream. I think actually what I may do, instead of going directly to this main state machine function, there's actually two things I should do. I should see if this is any closer, or how much closer it is on the PlayStation version. So we have the PlayStation and the PSP EU version of the game. If you have a modern port of Symphony of the Night to the PlayStation or to mobile, you probably have the PSP EU version of the game. And if you have a PlayStation disc, you have the PlayStation version of the game. There's also obviously the Xbox 360 version, the Saturn version, that's quite a bit different. And we're working on all of them. No work has been started on the Xbox 360 version except to kind of poke around a source code dump from it. Amazingly, PlayStation's already at 72%. Crazy. Let me undo that and see what it was. It's not going to compile with the... I should have caught that before saving it. Oh well. Pretty nice. So let's keep going. So we have some warnings. What I think I'm going to do, yesterday I did this and it didn't end up working out. I've done some more work and I'm hoping that it will work out this time. What I'd like to do though is see if any of the symbols or some of the functions that we were using but don't have symbols yet, if I've resolved any of those. So for example, this F158. So we're going to go through and look for some of those symbols and see if they are still present. I'm going to open up the symbols file. Usually I'm working on a much bigger terminal, which is why everything is so squished together in that other view. And what I want to see is whether or not these are still present, and if so, where they are. So we have, I'm pretty sure this became set step. No, that's still a thing too, okay. Fair enough. So we mostly have this 70 function. Let's go decompile that and see what that is. I'm gonna try to get some of these support functions, and then maybe we will learn something more about what's going on here. I use Vim primarily. You definitely do not have to. Use whatever text editor you like. So I'm going to create a new scratch. Prove to decomp.me that I am a human sometimes. And we'll see what decomp.me is telling us. So we have one read from an entity offset, the same broken pointers. This time coming from offset 1. Let's look at our Olrox entity extension. Yeah, so this is our unknown. So yeah, this is something native. And unfortunately, what it's telling us is basically what we already know and really not much else. So it's kind of a modified step, set step function. We know that it does take one arg, which is always nice to know. And we have one of these strange objects with offset 28 and 1C Audi TR909. And do we have... So we do know about 28. Alright, so I think I'm going to, just for the sake of it, I'm going to pull this struct over. Let's see if we can get this to match with what we currently know about this. Oh no. No, that's not the one I want. I wanted this one. I think that unknown 1C is no good. So we're going to cast this as a an unknown Olrox. So our load here goes into the S0 register fine. Unknown 28 here is being treated as a byte and not a half. Interesting. So let's break that up into 2. I don't know if that's going to affect the other code or not. And then unknown 28 is a byte as well. It looks like the load is happening here, and then and that matches. Okay, so we do have a match for this now. Unfortunately, it doesn't tell us a whole lot or give us any additional information. And I think that's just going to be the way that it is. So we still have this odd struct that we're having to deal with. But it does confirm, I guess, that we're taking one arg, and that arg type looks like an unsigned 8. That may help. Let's throw that in the context. Oh, I screwed something up, and I just realized. When you're building these contexts, you can't have macros, and so sometimes I'll copy them around, but really the PlayStation and the PSP need to be different because they have different fields. So I need to be a little more careful about doing it. Alright, so let's see. So we know that what the signature for that function is. So I'm going to throw it into the context. And that when we run M2C again in the future, now this will be there, and it can infer some of the types a little better, which is always useful. We may not have a function signature here. We need to be aware of that as well. If the function signature isn't there, the way arguments get passed is a little different. They get passed as ints instead of maybe masked down to a unsigned 8. So we just need to be aware that that could happen. Hey, roaming. All right, so we have that first one, which is this. Now let's... We could look at this 158 as well. We see a bunch of different things. Sometimes there's no args, sometimes there is args. That's not what I wanted. Computer, do the things I'm thinking, not the things that I do. Yeah, we're still... Hey, guest. Good to have you back. Still on the big thing. And I think we will be for a while. And so I'm trying to do things that support the big thing. Well, this is actually a pretty sizable function. Anything that we can get which helps us understand what the shape of that other struct is, I think is going to be useful. This one's big enough that I may pull the PlayStation version. Let's try to go through and see. We saw that, yeah, both of those same structs. So we do have something that's coming in and doing that. We do know that the function is void, which is helpful. So let's start on this one. So we're gonna, normally I would stay on that other one, but I think we have something we can do here. I didn't copy over my change. So let me get that. And does that help us or hurt us? Helps us. Good. So since we do need a drat. Let's see if we could do this. I should be able to declare this in context. This didn't work last time though, so I don't know why I'm thinking it's going to work this time. We'll see. So we're going to declare this here. Struct of this type exists. We're going to go grab our Olrox entity extension. And really, I don't care about the other parts, I just care about aurochs. And will this work for me? No, drat, I really wanted this too. Oh, I see what the issue is. Do I? I think I just need to prefix that? Yes. Okay. So we have that now. Let's get a new decomp. Very good. For the M2C's benefit, I will give it what I think this struct looks like. But I do want this just forward declared so that I can manipulate it as we go. And so let's see what we have. The first one is unknown BC. This is actually pretty nice. So what we're doing is grabbing the next entity, so the entity after current entity, and we're assigning it to field unknown 20. So we know that field unknown 20, which we don't have anything for yet, is a pointer to an entity. We had something else that was writing to unknown 22. So I hope that we don't have multiple. Oh, no. We're actually grabbing the first field of the entity. So again, that also helps us know what we're looking at. Looks like we're may actually be grabbing the first two fields, but we will see. Let's see. Grabbing the entity definition in my terminal. I think that's pos x. So I think, and did I make a comment about that? I did down here. So I'm gonna add pos x here. It's weird that we're gonna have, so this looks kind of like a shadow entity struct. And then pos temp s0 is temp s0 is not a primitive, it's one of these. Maybe we should start over again. I see. It chose prim, and it should have chose the unknown aurochs. Now we need to fix these fields, and we don't have this yet. So this is, like I said, it's the same as saying entity pos x dot val. And so unknown 20, it looks like we can make that pos x make that 32 pos x. And then offset 24, I was wrong. Offset 24 is pos y. And then it looks like we're going to do the same thing. It's the same variable, so I'm going to get rid of the _2 and just use the same variable. And we're doing something similar. The ordering here is probably wrong. Again, we have the same S0, so I'm going to just use... let's change all of the temp S0s actually to var S0. It does look like it is going to be a var. I'm not sure what M2C's heuristic is for choosing one or the other. Any unknown 20s need to be pos_x.val. This field came from the M2C thinking this was a primitive. I have to go find the primitive struct and figure out what offset x1 is at. That's at offset hex 14, and we don't have anything there yet. It's being read as a 16-bit value. What did I say it was? 14? So that's... oh, it is byte aligned. So it'd be the top of a float, if that's what it is. So we want to see if there is a U1. Are we using U1 anywhere? We're not. So I'm going to keep it at 16, but now assign 16 at offset 1414. We'll just call it unknown 14. And we'll add the additional padding for what's missing there. So any dash x1 is going to become, or pointer x1 is going to become unknown 14. Now we have unknown 2c. And we don't have anything there yet. This looks like an angle or a distance. So I'm going to say offset x and offset y for unknown 2c and offset 30. And are these being cast? So I think they're sine 32s. So any pointer to unknown 2c is going to be a pointer to offset x. And unknown 30 is going to be offset. Okay, so next we have unknown 10. Oh, did I do them backwards? I agree. However, var S1 is related to X. So I'm going to stick with what I've got. Does that make sense? Unknown 14 probably is an angle, but I'm not quite sure. Thank you. Yes. I never remember the equations for, besides like the Pythagorean theorem. I never remember those, so yeah, definitely check me on any of that. All right, unknown 10. Yeah, like I said, this looks like an angle. It's being read as a sine 16, so let's just throw it in as a sine 16, and I'll still call it unknown 10 for now. I'll make a comment though. Unknown 18. So 10 past 3 looks like our X position minus whatever distance that we're currently calculating. I'm going to name these two 10 past 5. That's going to become, no, 10 past 3 is going to become pos X. It probably is down here as well. SP38 is going to be pos Y. And these are actually both float values. So I should probably change that. They're a little more painful to work like that. Let's keep going and we'll get back to it. The more important thing is what are the types? Unknown 18 looks like a sine 32. And here I have it as a pointer, which is a problem. That may be a mistake. So I'm going to go with it being a sine 32 for now. Temp 0 is going to be, the same as var S0, so let's get rid of all those. Oh, I think you guessed. Giving me the equations for points on a circle. Perfect. RS1 I'm going to call angle. Looks like unknown 20 and unknown... unknown 20 is easy. And then unknown 24. Unknown 24. Oh, sorry, that should be specs. And this should be y.val. And we got 89%. Not too bad. Let's name some things. That'll make this easier. I'm going to call var s0. All rock struct, since we don't know what it is. Maybe we'll call it unknown all rocks. And let's split some of these up. So it looks like this current entity calculation is being done. The value is going into S8. A second one is being done. That value is going into S7. And let's mark those. And make sure that I'm using them the right way. So those are fine. Oh, this looks okay. So if you're new, what I'm doing is trying to get the C code to match the compiled machine code here, and this is the output of mine. So I'm looking down this column to see where differences are between the two, and then I will update as I go along. So this value right now, the pos x and pos y's, they're getting pushed to the stack pointer, or sorry, they're getting pushed to the stack. So we end up with calculations on the stack pointer. As I get rid of other variables, that will go away, and I won't have to deal with that in the future. So I'm going to ignore those for now. The mask here on 58. Oh, duh. This is being treated as a Boolean. I was called out on that already. So again, things are being loaded from the stack. Temp S5, we have a bunch of different uses of those, but they're all probably the same thing. So I'm going to get rid of the _2 version, and hopefully that tightens up the stack version, or the stack a little bit. Same thing with the S4. Most of the time on smaller functions like this, the correct thing to do is use the same variable when the same register is being used. Not always true, but most of the time. So then the other part of this is these other variables, temp s3, etc. Let's try to consolidate those as well. Like that. Let's do these first. RS2. I don't see RS2 as being different from angle. Let's look at 93 and see if RS2 is being used. It's RS3 here. So we may have two different angles. I'm going to try to use just the one angle variable. I think that so. Okay, so then let's name a few more things and see if we can clean that up a little bit. Temp S5 I'm going to call offset X. Match the field. I don't know if it's a good field name, but that's what I went with. Temp S4 then is going to be offset Y. Yeah, I do think unknown 10 should be angle. I agree. And as these get named, I'm going to move them up. SP3C. So these look like a variation of pause X and pause Y. If pause X and pause Y are not getting used again, they are, so we can't overwrite them. And you start running out of names. I'm gonna call these target pause X and pause Y, I think. So we're calculating the distance to something, and basically this is where on the screen minus the distance. So I think that's fair. But then what? Like, this is a poor man's Pythagorean theorem. It looks like. What would be the point of? Oh no. This is also an offset, like our target offset. Yes, let's call it that. So I'm going to call temp S6. I'm going to call that target X. SP3C. Target Y. I don't know if those are good names or not. But those are the ones I'm choosing. Not sure what the 1C is coming from. I don't see what the value in that is. We're doing, so it's getting converted into shifts. I do see the value of a shift by 12. And my guess is that maybe that's what this is should be a shift by 12. But it's not. So I'll have to get an Olrock save point and see. Yes, I agree that it's, that sounds right, guest, that it's something circling around something. I don't remember the boss fight enough to say offhand what that might be. Okay, so now our stack is actually, it looks like, possibly a little too small. So we have value getting pushed to the stack there and loaded back. Maybe it's actually too big. Let's clean up these other things and then we're gonna have to go variable hunting. Okay. So that's the next unfortunate step. My least favorite is starting to go variable hunting. So our unknown Olrocks is S0. What the correct order is may not matter. We'll see. Sometimes it does, sometimes it doesn't. 57. This is going into S1. Oh, I screwed that up. I looked at the wrong column. It is S1, so it doesn't matter. S5 for offset X. S4 for offset Y. S3 for pause X. Stack pointer for pause Y. Okay. S6 for target Y. And oh, I read that wrong. Offset 3C for target Y? I think so. S3. looks like offset 38 which is the same as this pos y in pos x. So we know that we have that temp v1 is pos y and temp s3 underscore 2 is pos x. Okay, so we're getting close. So we have a store to pos y, or it's going to the wrong location on the stack. See anything? Too crazy about that. So we're loading offset 24 into V0 and then storing V0 back to offset 38. So for some reason we're not using the S2 register at this point. Let's see what S2, or sorry, yes. And so there could be a variable that's missing. So it looks like thank you. Pos y equals pos y. That doesn't help anything. Let's look at what the original. I'm going to throw this back. So this seems stable now, which is good. So the SP38 equals temp1. That makes sense. Why that was pos y equals pos y. Down from the top again. And my concern here is that, so it could be variable ordering, it could be that I'm using the wrong, or I'm missing a variable. And chained assignment, ooh. Interesting. Do you have a suggestion as to where? There's some things like this too, where this is a negative value. So this is -4, fix -4. I'm going to go through registers, I think. Yeah, the other thing is these likely are the multiplications here are a little strange. Actually, let's do this. This is pretty good the way that it is. I'm going to grab that FFFC value. Let's find the PlayStation version, and maybe M2C will be a little nicer. So only a few functions with that. And let's see if any of those have, I'm guessing many of them will, all of them. Any calls to R sine or R cosine? Yes, they all do. Yeah, both unknown 10 and unknown 14, yeah. Oh, actually that is a little different than I was... Shoot. I screwed something up. I'm looking back at it. So when we're dealing with an angle, yeah, we're dealing with the PlayStation fixed point values, which are 12 bits for the fraction and 20 bits for the whole number portion. I just want to make sure, so we call that a float, FLT, even though it's not float. The Konami 1616 numbers we call fixed. They're both fixed, they're just a different format of fixed. And so anything going to the SDK functions like sine, cosine, etc., they're all going to take that PlayStation format value, and that's what they're going to return as well. And so you just have to make sure that you're keeping those straight. That's also, yeah, like I said, that's also what they return. And so we see a lot of code that's shifting those back to one format or the other. Usually it's dropping off the decimals, but it could be, yes, the multiply by 4. I think these are probably out of order. I think that this is like a float to fix, which is a shift by 4, which is, that's the same as a multiply by 16, right? But the ordering there is wrong. So when that conversion happens, I think is, I don't know if we have a float to fix function or macro. That'd be a good one to have. 14, 4. Yeah, so I think these are going to be written more like this. Yeah, I don't see a macro for that. We should have a conversion macro, because that's a pretty common conversion. So then the 1C is just a multiplier. Okay, anyway, going back, trying to find this function. What other unique values do we have? Let's look for that OCO. It's in all of these as well. They're all doing the same calculation, it looks like. And I'm guessing they all use an entity. Of course. Is there anything else unique about this? I don't think so. So let's just go back to the beginning then. We have 3 functions. One of these is going to be the right one. Oh, duh. Here's how we find it. We look at where this is in our mega function, 253. Find it in our PlayStation function. And then see what the symbol should be. That was easy. I am going to have to call it a day, unfortunately, so we're not going to get to see the end of this. Let's do this quickly. Try to get as much as I can. See how close we are here. Uh-oh, what did I do? Oh, I screwed this up. Real bad. Oh, did I save? Oh, okay. That's what I did. Copying, pasting. Too many places. Not respecting my tab order. Not terribly important that this is correct. Not being correct is troubling to me. Because that means I changed something along the way. I see. Okay, so we'll leave it there. Making edits to things that I don't know about. Oh, this is actually pretty interesting. So we have a 4-byte offset between the two, which means there's additional padding on the PSP version that there isn't in the PlayStation version. So our Olrock's struct, this first 32 bits may not actually be there. And unfortunately, we don't know where. We do, but it might not be there. It may be after one of these primitives, but there's an additional 24 bits somewhere in here. So we'll have to deal with that eventually. Let's look at the decom. So this all gets pre-multiplied here, which makes sense with the optimizing compiler. What did I come here to figure out? I don't know if there's really much. I think I was trying to figure out the shifts, but anyway, we'll come back to it tomorrow. Obviously mostly there, 99.32. The offsets there being wrong is interesting. It looks like this one is just offsets. So we have an additional 32 bits somewhere that we need to get rid of. And where that is, not there. Okay, so that matches. Like I said, I don't know. It's somewhere early. But we don't know where specifically. But this does give us a match, as is on type sometimes on the PlayStation. So unfortunately, the PlayStation version didn't give us any help except to confirm that logically this is probably correct. We just need to figure out what is missing from the layout of the rest of the code. So go to soten.z.dev to learn more about the project, and I'll talk to y'all next week. Adios.